So now I'm going to go through and I'm going to work the problems for 6.1 out of your textbooks. And what I really want to make sure that you guys use this video for is just to check yourself or to use it if you get really, really stuck. Part of the point of this is to kind of help you learn through struggling a bit. Please don't use this just to copy stuff down and then just go through. I'll be keeping an eye on you. Please make sure that you're actually using this to try to do the work ahead of time and then check as we go through. Now, hopefully you've taken the time. If you haven't, please do so now to pause the video and read all of the things that you're going to learn today, the learning goals for this, some of the vocabulary words that you're going to learn, and a little real-life introduction to some of the content that is going to be involved in today's activity. I'm assuming that you've done that. So now we're going to go through and we're going to look at the first page of material. It says a right triangle is a triangle with a right angle. Remember that we can tell because of that little box right there in the middle. That is something that we should know from our background knowledge. A right angle has a measure of 90 degrees and is indicated by a square drawn at the corner to form an angle. A leg of a right triangle is either of the two shorter sides. So out of our triangle that we have here, it's nice and labeled for us. Here's a shorter side, and here's a shorter side. So these are the two legs. Together, the two legs form the right angle of a right triangle. So you see here your legs, there's your right triangle, or I'm sorry, your right angle in between them. And the hypotenuse of a right triangle is the longest side. So the hypotenuse right there is the longest side of the right triangle, and it's opposite of the right triangle. And this is true for every single right triangle. You always have the two shorter legs on either side of the angle, and then you always have the hypotenuse, which is the longest side opposite of the right angle. Number 1 asks, the side lengths of a right triangle are given. Determine which length represents the hypotenuse. Do not just copy this off of the video. If you haven't done it already, pause the video, try to work it yourself, and then check to make sure that your answer is correct. I'm assuming that that's what you've done. So this says the hypotenuse is the longest side up here in our paragraph of text. So that means out of these three, we need the longest side. So that means that for A, the longest of those three numbers is 13. So the hypotenuse is the 13. I'm going to come back to B in just 1 second. Here the longest is 5.1. Here the longest is 75, 39, and 25. Looking back at B, and again, I got those because they were all the longest side of the three of them. Right here at B, some of you might have forgotten what this means. The reason you needed to pass square roots before you could actually work on Pythagorean theorem is because we need to know what that symbol means. And that symbol means, I'm going to go use a simpler example down here. Square root of 25 means what number times itself gives you 25. If we haven't, if this isn't ringing a bell, make sure that you go back and we have a whole wall that has some stuff with square roots that you can do on it. But for our little mini review, if you need it, remember, you just think to yourself, what number times itself gives you 25? So that would be 5. Square root of 36. What number times itself gives you 36? Well, that number is going to be 6. And so now we need to go back up here and look at the square root of 2. And of course, I'm sitting and I'm thinking, and I can't think of a number that times itself is going to give me 2. That's because the numbers that I used for my examples down here are what we called perfect squares, which means they come out to be even perfectly whole numbers. Okay, so we don't have a whole number. There's no such thing as a whole number that times itself is going to give you 2. From previous lessons, you've seen how to use your calculator to figure out the square root of 2. So if you put that in your calculator, you know it's going to be about, and I'm totally rounding to the nearest tenth, but it's going to be about 1.4. So that means that out of these three numbers, we've got 1, 1, and 1.4. The square root, I'm sorry, the hypotenuse must be the square root of 2 because it's the longest side. Finally, how did you decide which length represents the hypotenuse? Should have said something along the lines of the hypotenuse is the longest side. Now, through a series of learning activities, we are going to explore some properties of right triangles. It says, in this problem, you explore 3 different right triangles. You will draw squares on each side of the triangles and then answer questions about the completed figures. A diagonal of a square is a line segment connecting opposite vertices of the square. So let's make sure we remember what a diagonal is. So, of course, this is a greatly drawn square, but that's okay. It says it's a line segment connecting opposite vertices. Okay, remember that this is a vertex. A vertex is the corner of the polygon. So that means the diagonal of a square, when it says it's a line connecting opposite vertices, they mean it'll be a line that looks like this. So just like a diagonal line. We know what a diagonal line is. We're playing tic-tac-toe. We know what up and down and across means. This is what diagonal means. So this is what a diagonal of a square would look like. Okay, so now we've got to make sure we follow a lot of directions. So if we're getting lost at this point, I really don't want you to just use the video. I want you to just do what the video says. I really want you to read the directions yourself first, try to do what it's asking you to do, and then go back and restart the video to make sure you did it right. So it says isosceles right triangle. Remember, isosceles means that 2 sides are the same length, just like the ones we have here, is drawn on a grid shown on page 317. So you should flip to page 317 of your packet. So the square on the hypotenuse has been drawn for you. So you notice that they drew a square right here along the hypotenuse. Remember, the hypotenuse is the longest side. It says use a straight edge, in other words, a ruler, to draw squares on the other 2 sides of the triangle. So you notice that the square is the same length as the sides, as the side of the triangle that's given. So what they're asking you to do is actually draw squares, just like this one, that are the same length as the side of the triangle. I want you to pause the video, try it yourself. I'm assuming now that you've done that. So because the length of this square is 1, 2, 3, 4, 5, I'm sorry, the length of this side of the triangle is 5. That means I'm going to draw a square that's 5 wide and 5 long. So 1, 2, 3, 4, 5. 1, 2, 3, 4. So I drew one square along that side that's 5 by 5, because this one is also 1, 2, 3, 4, 5. So this is what it should have looked like. In the next part of the directions say use different colored pencils to shade each small square. Okay, we are not using colored pencils in this class. We're going to be using markers. Make sure that as you're coloring them in, that you don't have your other pages underneath, because sometimes they like to bleed. But, so I'm going to color in one of my rectangles and the other one. So far, all we're doing, guys, is just following directions. The only thing we might have needed some clarification about is exactly what size these squares are supposed to be. But since each side of the triangle is 5 long, the rectangle or the square just needed to be 5 by 5. This is a picture of what mine looked like in real life when I did it. And let's look at the next set of directions. Okay, so we use colored pencils to shade each small square. So that's what I did. It says different colored pencils. You'll see why it's important in a minute. So that's what mine looked like. Then the next set of directions said, draw 2 diagonals on each of the 2 smaller squares. So the 2 smaller squares, I took and I drew straight lines from one corner to the other corner, one corner to the other corner. If you haven't done that now, make sure that you pause the video and that you do that. Then it said to cut out the 2 smaller squares along the legs. So that means I needed to cut out those 2 smaller squares and then cut out the 2 smaller squares along the legs. Then cut those squares into fourths along the diagonals that you drew. That means both of those squares that started out divided into 4 pieces. I cut along those 4 lines and cut them into 4 individual pieces. And directions say, redraw the squares on the figure in the graphic given on page 327. So if you flip to page 327, you'll see you'll have a graphic that looks almost exactly the same as what you were just using. Now it's just inside of a green graphic organizer. So as you can see, I redrew my 2 squares on my graphic organizer, exactly the same as what it looked like when I just did it. Oops. Here on my original grid. The only difference is that now it's inside of the graphic organizer. It says shade the smaller squares again, which I did. Now, letter E says arrange the pieces you cut to fit inside the larger square on the graphic organizer. So that means these small pieces that I cut earlier, I need to rearrange them and try to fit them inside of the bigger square that's on my graphic organizer and then tape it down. I want you to try to do that before you watch the rest of the video to see how to do it. So everybody hit pause. Then you try to fit those smaller triangles into the bigger triangle. So hopefully if you did what I asked you to do. Okay, so yours might look something like this. This is how I chose to tape in the 2 different colored, but you'll notice that all 4 of the blue triangles and all 4 of the green triangles fit into that large square. I've just taped them down so that they fit in there and that they don't blow around. And the question says, enter these questions in the graphic organizer. So you'll notice that on the sheet or on your graphic organizer, there are actually these questions for you to answer, and they match the 3 questions that you have here. So you don't need to actually answer the questions here on the page. You really need to answer them here on the graphic organizer where you just did that taping. I would like you to pause the video again, try to figure out your own answers to the questions, then restart the video when you're ready. So what did you notice? I noticed that the 2 smaller rectangles, or smaller, well, rectangle is a square, so sorry I keep saying square, but it really means the same thing. Smaller squares fit together into the big one. I'm actually going to make this a little bigger. I got a little more room to write. So the 2 smaller squares fit together into the bigger one. Describe the relationship among the areas of the squares. Remember last year we did area to depth. To find the area of a square, you do how long the square is, which is 5, times how wide it is, which is 5. 5 times 5 means the area is 25. And you can tell just by looking at it. Remember, area is made up of square units. If you were to take the figure and figure out how many squares fit inside of it, there's 25. So the area of this one is 25, and the area of this one is 25, because 5 times 5 is 25. So describe the relationship of the area. Well, if these 2 triangles, or these 2 sets of triangles that you make from the 2 squares cut up all fit into that big rectangle, well then it must be that the area of the 2 smaller squares added together equals the area of the larger square. So if we took the area of these two squares, which we did, we kind of chopped them up, put them together and mixed them up, but they all fit into that larger square and they fit in there perfectly. That means the area of the two smaller squares added together must equal the area of the larger square. I'm going to put this a little bit more mathematical terms also. What's the word for when you add things together? Well, the word is the sum. So the sum of the two smaller squares equals the area of the larger square. We'll just have to write it from there. Let's try that again. Okay, the sum. And guys, I want to make sure when I check for this, I'm going to be looking to see if you didn't use the word sum before, make sure you add it in there. Because whenever you're looking at textbooks and examples in your future, they're going to use that word sum instead of just saying you add things together. So I want to make sure that you know what it means. So sum, so if you add together the area of the smaller squares, it's equal to the area of the larger square. The final question in problem 2 is a little bit, actually this will probably be the hardest thing you do most of the day. And says determine the length of the hypotenuse. So that means figure out how long this hypotenuse is right here. I'm going to make this a little bit bigger and hope we can see a little better. Okay. I'm going to tell you, hopefully you've actually paused this and you've tried it on your own and you've restarted it. Here's what a lot of kids would say. And all I'm going to tell you right now is that it's not quite correct. Okay, so for these two squares, you can count, right? You can just count that this is 1, 2, 3, 4, 5 units long. So this side of the triangle is 1, 2, 3, 4, 5 units long. And this side of the triangle is 1, 2, 3, 4, 5 units long. What a lot of kids would do is count these little places right here. Like there's a little line segment. So they'd say like this is 1, 2, 3, 4, and maybe count this as like a half and another half. So maybe this is 5. Okay, we know from earlier in the lesson that the hypotenuse is always the longest side. So you can tell right here, the hypotenuse is always the longest side. So that means that we can't possibly just count and this turned out to be a 5 because the hypotenuse isn't going to be the same length as these other two sides, which are 5. Plus, we can kind of tell by looking at this that it's longer than the other two. But we know for sure, because these line up perfectly with these squares, that they're 5. So that side can't be 5. So a really super common mistake that a lot of kids make is they just try to count from here, and that doesn't work. Because actually, the distance going straight up and down the square is not the same distance as going diagonally across the square. So we can't just count this. We've got to figure out another way. I want you to take a little bit and try to think if you can see if you can think of a reason or of a way to figure out. If you can't just count to see how long this square is, what might be another way to figure out how that works? If if you've tried, and I really want you to stop the video, try and really think, really think, really think. If you think you've got it, put down an answer and actually bring it to me to check in class. I'm going to actually stop this video right now. If you've thought about it and you just can't figure out an answer, then what I want you to do is go on to the next video. It'll say 6.1 problem 3, because that's the name of the next one that you're going to do. And I think that if you do problem 3 before you finish this problem, it might help you to figure out what to do. But again, if you're pretty sure you know what to do, go ahead and write the answer down, bring it to me and check it. If not, then I'm going to have you do the next one.